All right, so welcome to this week's Unikernel application spotlight. This week we're looking at MVM. I don't know what the hell it stands for, but it is a fast virtual machine for Go. So there's a couple other Go compilers and VMs out there that besides the official one. And this is apparently the guy who wrote this. This is his second one. He threw the first one away and rewrote it. Um, it's supposed to be kind of a quick little thing. You can embed it and so forth. Obviously, the REPL is a big deal with it. And yeah, it's pretty basic. This is the GitHub that you can go check it out. And the GitHub is worth checking out because there's lots of different things. This entire folder here, for instance, has ADRs, which basically explain a lot of design decisions that he decided to take. And then we got our samples and so forth. Quite a few in here. There's a lot of like random stuff that's in this that is kind of different, and we'll try to get to it. But also has architecture overview. So kind of how it actually works. Yeah, and so there's a few different things that are slightly different than like say your average Go compiler, for instance. Right off the bat, you can do this MVM run. That's slightly different as far as I understand. This is different than a doing Go run, for instance, which I think a lot of people do, which I actually never do, by the way. But yeah, so you can do MVM run, and what happens is it's going to throw it up on as bytecode on the VM runtime that he has. So it is a little bit different there. And of course, you can start scripting with it. You have the REPL and so forth. And there's just a little different tweaks that you might see when running a VM. For instance, you don't need package main, func main, that sort of stuff, because obviously you're just typing it into a REPL. It has some tracing to where you can kind of get bytecode. Again, this is not really something that you're going to find in Go per se because Go's compiled language, right? But this is something that you would need if you had a bytecode VM, which this is. It has an interactive debugger, so you might be familiar with like Delve or something like that. This is different. You can throw in traps and so forth, and you can kind of just walk through it. So that's kind of interesting and new. Remote imports. Now this can be dangerous. I'll just say that. But it's also kind of interesting if you want to just immediately, yank some code and start screwing with it, right? So he has this little example here where he runs, basically goes out, downloads Google's UUID package, and then immediately starts running it, kind of all on the fly, which is interesting. It's not really something that you do in Go normally, but that's interesting, right? And yeah, so I mentioned that you can embed it. Well, so this is him embedding Go within Go, which is kind of kind of different. But I can already kind of think of a couple of situations where it'd be like, yeah, it'd be kind of cool to like script some Go and then eval it and then pipe it back out all within a running compiled Go program. So yeah, that's kind of interesting. Capability right there. This is running in C. The embedding of it. So it's easy to access, and obviously, if you can access it via that way, you can easily script your code, where maybe it's not so convenient otherwise. So that's kind of cool. Benchmarks, he's got a couple on here. States right off the bat, micro benchmarks are not real world performance, which is a good thing to state. But yeah, he compares against Lua and Python mainly. And so it's, it's relatively fast with the stuff that he's showing. Obviously, this isn't going to probably be faster than like an actual compile Go program because there is a cost to having the bytecode VM, right? And that cost is actually, fairly high when you're comparing like a VM to a compiled language. I mean, that's just facts, right? Then he has this compatibility matrix, so showing kind of like where everything is compatible and not compatible. And again, this is like one of those sayings where it's you're just going kind of in an opposite direction than what the language has, done. And so obviously there's going to be differences here. And it's kind of interesting that they got all of this that's pointed out. Remember when I mentioned the remote imports, like you can imagine this test framework. I haven't even looked at it, but you can imagine you can do stuff like that, where you can just kind of test remote stuff on the fly. All right, so you can go ahead and run this, and we will do so. And our example here, config is pretty basic, just pass in the high go. And we got our sum of squares here. So basically it's an iterator. It's just going to take a sequence of 1 through 4. It's going to square them, and then it's going to add them together. So 1 and 1 is 1, 2 and 2 is 4, 3 and 3 is 9, and 4 and 4 is 16. So 1, 4, 9, and 16 all added up is our number that we're looking for. So we're going to go ahead and run it. Boots up, and it took a second. I'm not sure what happened there. Yeah, okay. So, and it outputs 30, which seems like a reasonable number if you add up all those. But yeah, it's pretty basic. The package is nothing's in it. It's just this. So really nothing at all, and nothing special was done. But this was MVM, a fast virtual machine for Go, and now it's running as a Nanos Unikernel. All right, till next time.